Welcome to the Health Headliner podcast by Tudu Digital. Our content is informational only and not medical advice. Please consult your provider. Now, let's dive into today's headlines.
Have you ever, found yourself mid-sentence and just completely blanked or walked into a room and thought, wait, why did I come in here?
Oh, absolutely. It happens to everyone, I think.
It's so common, right, and frustrating. It turns out that as we get older, some decline in brain function is pretty normal, part of healthy aging, especially something called working memory.
That's right. Your brain's sort of mental sticky note pad. It's crucial for, well, almost everything. Remembering a phone number just long enough to dial it, following directions, even keeping track of a conversation like this one.
Exactly. But what if? What if there was something enjoyable, something fun, that could actually help push back against that decline?
That's the really exciting part.
So today we're doing a deep dive into some fascinating new research. It's from Kyoto University, just published in Imaging Neuroscience.
Yes, a really interesting paper.
And it gives some, pretty compelling evidence about picking up a musical instrument later in life, even if you've never played anything before.
Even in your 60s, 70s, or beyond.
Our mission today is to unpack this study, how they did it, what they found about specific brain regions, and most importantly, what it all means for you and your brain health down the line.
It's definitely timely because, people are living longer, and while our brains are adaptable, this cognitive decline, particularly in working memory, is a real challenge that comes with healthy aging.
And you mentioned specific brain areas.
Yes, two in particular seem quite vulnerable. There's the putamen, that's the structure deep in the brain involved in learning, habits, and movement, and the cerebellum back here.
The cerebellum, I usually think of that for balance and coordination.
It does that, absolutely, but it's also heavily involved in cognitive functions, timing, attention, and both these areas can shrink a bit, show reduced activity as we age.
Right, and most research on music and the brain, it always seemed focused on kids, prodigies, or people who played violin since they were 5.
Exactly. We knew physical activity helps, mental puzzles help maintain memory generally. But the big question was always, okay, I'm 70, I've never touched a piano. Is it actually too late? Can starting now still make a real difference to my brain?
Can you genuinely protect your mind by picking up, say, a guitar at that age?
That's the gap the Kyoto team wanted to fill. Their goal was specifically to look at the long-term effects. Does starting music training in older age actually lead to sustained benefits years later?
And this wasn't their first look at it.
No, they actually did an earlier study back in 2020 which showed some short-term improvements. So this new research was a follow-up, tracking people over several years to see if those initial gains held up or even grew.
Okay, so tracking people for years.
Yeah.
How did they actually set that up? That sounds complicated.
It is, yeah. It requires a lot of commitment from everyone involved. They recruited participants from that original 2020 program. These were all healthy, older adults, average age around 73 when they first started the music training.
73, okay.
And they tracked 32 of them for about 4 years after that initial training phase ended.
Wow.
And what's really interesting is how the groups formed. It wasn't assigned. People sort of self-selected based on what they chose to do next.
So naturally falling into groups, how did that work?
Well, one group, they called them the Continue group, 13 people, average age nearly 78 by the end of the 4 years. They just kept playing. They practiced their instrument for more than 3 years during that follow-up period.
Okay, the dedicated musicians.
And the other group, the Stop group, 19 people, average age 76 by the end, they stopped the music practice after the initial training and switched to other hobbies instead.
Ah, okay. And critically, how similar were these groups at the beginning?
That's vital for comparison, isn't it?
Yeah.
At the baseline, before any long-term divergence, both groups were completely new to musically untrained, and they were matched very well on age, education, general cognitive health. So, a fair starting point.
And the Stop group, they weren't just sitting around, right? They were active.
Absolutely crucial point. No, they weren't inactive. They were doing other things, table tennis, gymnastics, stretching classes. So the study wasn't just comparing, musicians versus couch potatoes. It was comparing continued music activity versus other types of leisure activity.
That really isolates the music factor then. So what instrument were they learning? Was it something complex?
They used the melodica.
The melodic, the little keyboard you blow into.
Exactly. It's actually a great choice for this kind of research. It engages multiple senses. You've got the finger coordination on the keys, the breath control, listening to the sound, reading the music.
Makes sense.
And the Continue group, They didn't just practice alone. They formed a Melodica club. They met weekly for group lessons. They practiced at home. They even gave public concerts.
That's fantastic. Performing in public, that adds a whole other layer of motivation and complexity.
Definitely. Their training involved learning to read basic scores, exercises for finger dexterity, and they worked on progressively harder pieces over time.
So after these 4 years, with one group playing in concerts and the other doing gymnastics, how did the researchers actually see what changed? How do you measure brain benefits?
They used a combination of approaches. First, brain scans magnetic resonance imaging, or MRI, to look at the actual structure, the physical volume of brain regions, especially focusing on that putamen and the cerebellum we mentioned earlier.
Looking for physical changes.
Precisely. And then they also did cognitive tests. Behavioral measures. They looked specifically at verbal working memory using a combined score from tasks like digit span remembering sequences of numbers and verbal fluency naming words and categories.
Okay.
And they also assessed other things, like delayed recall of a story and a test called the trail-making test, which measures executive functions like mental flexibility. A really comprehensive look.
All right, the moment of truth. 4 years later, did the melodica players fare better? Did the music make a tangible difference?
The results were pretty striking, especially for verbal working memory. The continue group, the ones who kept playing music, showed no decline in their verbal working memory performance over those 4 years.
No decline at all.
Essentially, yes. Within the bounds of the measurement, their scores held steady. Think about that. While aging typically involves some drop, these individuals, averaging nearly 78, maintained their baseline performance.
That's huge. What about the group that stopped playing music?
That's where the contrast is clear. The stop group did show a significant decline in their verbal working memory scores over the same 4-year period.
Wow. So playing music seemed to actively protect that specific function.
It really suggests that, yes. It's interesting, too, that other cognitive measures, like remembering the story after a delay, didn't show such a clear difference between the groups. The protective effect seemed most pronounced for this verbal working memory component.
Okay, that's powerful on the functional side. Their memory worked better. But did the MRI scans show anything? Did their brains look different?
This is where it gets really compelling, connecting the behavior to the biology. The MRI scans showed that the continue group did not experience a decrease in the gray matter volume of their right putamen. It held steady.
The putamen stayed the same size?
Essentially, yes. But the stop group, they showed a significant decrease in the volume of their right putamen.
A measurable loss of brain tissue in that area.
Exactly. And remember, the putamen is deeply involved in learning and processing working memory. So playing music appeared to literally help preserve the structure of this key brain region.
That's incredible. What about the cerebellum?
The cerebellum was slightly different. Both groups actually showed some age-related decline in the volume of the right cerebellum over the 4 years. However, the decline was less significant in the continue group compared to the stop group. So while music didn't completely halt the age-related change there, it seemed to slow it down.
Slowed the decline, okay. And did they link these brain structure changes directly to the memory performance?
They did. They found a significant correlation. The better preserved the gray matter volume in the right putamen was, the better the individual's verbal working memory performance was maintained. A direct structure-function link.
So the brain structure supports the function. Makes sense. What about how the brain regions were talking to each other? Did they look at brain activity or connections?
Yes, they looked at functional connectivity, how different brain areas coordinate their activity during a task. And here, too, they found differences. During the verbal working memory task, the continue group actually showed higher activity, spread over a wider area in both sides of their cerebellum.
Higher activity, does that mean their brains were working harder?
Not necessarily harder, perhaps more effectively. It suggests they were better able to recruit the resources within the cerebellum needed for the task. But here's a fascinating twist.
Okay.
They also showed lower functional connectivity between their cerebellum and a part of the brainstem called the pons, specifically during that verbal working memory task.
Lower connectivity. That sounds bad. Doesn't more connection mean better communication?
You'd think so intuitively. But in this context, lower connectivity can actually mean higher neural efficiency. Think of it like an expert team. They don't need constant chatter back and forth because their internal processes are so streamlined.
Ah, I see. So less effort needed for the communication pathway.
Exactly. It suggests their brains were achieving the same or better performance, but with more optimized, efficient neural communication between these specific areas. Smarter, not necessarily harder.
Wow. The brain becoming more efficient through musical practice even later in life. That's really something.
And there was more along those lines. When they looked at a visual working memory task, the continue group showed signs of the cerebellum becoming more efficient internally. They had increased connectivity within the cerebellum itself.
Okay, strengthening internal links.
And decreased connectivity between the cerebellum and a part of the cortex, the right supramarginal gyrus. Again, this pattern suggests the cerebellum was becoming more self-reliant, handling the task more efficiently without needing as much compensatory input from other cortical areas.
It's like the cerebellum was getting better at its job and needing less outside help.
That's a great way to put it. It points towards increased specialization and efficiency within that crucial structure.
These findings just seem incredibly positive. What did the lead researchers say? Were they surprised by any of this?
The corresponding author, Kaoru Sekiyama, mentioned that. She said, we were surprised to find that the effects on the brains of elderly people who start and continue practicing an instrument were also concentrated in these two areas of the brain, the putamen and cerebellum, and that this was an effective way to prevent age-related decline.
So even the researchers were struck by how targeted the effects were.
Yes. And Sekiyama also pointed out a very practical aspect, she noted. For those who struggle to engage in physical activity due to body pain or other problems, playing musical instruments can be a great alternative.
That's a really important point for accessibility. So bringing it back to the listener, what's the big takeaway message here?
I think the message is profoundly hopeful. It really does seem that it's never too late to start playing music. And doing so, starting even in your 70s or later, can have real, measurable benefits for your brain, specifically helping to protect your verbal working memory against age-related decline.
And it does this by actually preserving brain structure, like in the putamen.
Exactly. Preserving structure in the putamen and enhancing the efficiency and function of the cerebellum, both absolutely key for memory and cognitive control.
Why, though? What is it about playing music that does this? Is it the notes? The rhythm?
It's likely a combination of the complex demands music places on the brain. Think about playing the melodica, or any instrument, really. You need incredibly precise motor control fingers, maybe breath, posture. You need to synchronize your actions with the beat. Keep time. You're constantly using your working memory, holding musical phrases in mind, reading ahead in the music, anticipating what comes next, integrating hearing, seeing, moving.
Here's a full brain workout.
It really is. And this constant, complex engagement, this coordination of senses and actions, likely strengthens the neural pathways and preserves the structure in those heavily recruited areas like the putamen and cerebellum. It fits with the idea of use it or lose it, but in a very specific, musically driven way.
That makes a lot of sense. Now, no study is perfect. We should probably touch on the limitations, right? What caveats did the researchers mention?
Absolutely. Critical appraisal is key. And they were upfront about limitations. First, the sample size, 32 participants overall, split into two groups, is relatively small. Larger studies would definitely help confirm and generalize these findings.
More people means more statistical power.
Exactly. Second, there's the self-selection issue we talked about. People chose to continue playing or not. So motivation, or maybe just innate musical interest or aptitude, could have played a role in the outcomes. It wasn't a randomized controlled trial where people were assigned to groups.
So the continue group might have just been more motivated or enjoyed it more to begin with.
It's possible, yeah. That could influence the results. Third, the study focused on the melodica. While it's a great instrument for research, we can't be certain that learning, say, drums or the violin would have the exact same pattern of effects. Different instruments might tax the brain in slightly different ways.
Good point. Different demands.
And finally, one interesting point they raised, the continue group was actually slightly older, on average, than the stop group.
Older? Wouldn't that work against them?
You'd think so. Since working memory decline can sometimes accelerate after age 70, the fact that this slightly older group still showed preservation might mean this study actually underestimated the true protective power of the musical training. The benefit might be even stronger than it appears in this comparison.
Huh. So the results might be even more robust. Okay, so let's try and sum this up. This deep dive really highlights that sticking with musical instrument training, even if you start late in life,
can actively fight back against that common age-related slip in verbal working memory.
And it seems to do this by physically preserving parts of the brain, like the putamen, and making other parts, like the cerebellum, work more efficiently.
That's the picture emerging from this research. It's a compelling case for the power of lifelong learning, and specifically musical learning, for brain health.
It really drives home that message. It is truly never too late. Not just for the joy of making music, but for actively investing in your cognitive future.
Precisely. The benefits go far beyond just learning a new skill.
So, listening to all this, it really makes you think, doesn't it? Given these incredible insights, what new skill, maybe a musical one, maybe something else might you consider picking up? What hidden brain benefits could be waiting just around the corner? Imagine not just the fun of creating something new, but the amazing bonus of potentially keeping your mind sharper for longer. What will you learn next?
Thanks for tuning in to the Health Headliner podcast by To Digital. Like and subscribe for more health news and breakthroughs. Stay healthy and informed. See you next time.